growth in carbon dioxide emissions is a long-recognized contributor to a rise in global temperature. The signs of a warming planet are all around us. Rising seas, melting ice sheets, extreme weather events, record-setting temperatures, and agricultural disruptions, along with further impacts, cascade across ecosystems to human and our economy. The measured change from 280 molecules to 380 molecules of carbon per million molecules of air since pre-industrial times shows that this is a problem that can no longer be ignored. As engineers work on ways to capture and store excess carbon dioxide to stem global warming, the men and women attempting to solve this grand challenge must consider the world's extreme dependence on fossil fuels. The political, economic, and social legacy of carbon dependence stemming from even the very first coal plant is an additional inherited constraint that modern engineers must work around. The global dependence on fossil fuels is unlikely to diminish in both first world and third world nations, even with the growth of new, more efficient, and affordable renewable energies. Engineers must thus develop systems for capturing the carbon dioxide produced by burning fossil fuels and sequestering it safely away from the Earth's atmosphere. The National Academy of Engineering's Develop Carbon Sequestration Methods Grand Challenge was created in an effort to increase awareness about this crisis and encourage the development of economical and effective solutions to the global carbon issue. Our group chose this specific project due to the recent proliferation of global warming discussions within the national news cycle, making this challenge both immediately consequential and informative. Additionally, global warming is an issue that connects everyone on the planet. No one is or will be excluded from its devastating impact.
In order to keep carbon dioxide away from the atmosphere, one solution is to store it underground. One way engineers can store carbon beneath the Earth's surface is by pumping it into old oil and gas fields. This method is already in use as pumping CO2 into oil fields causes it to react with the oil, which decreases the friction between the oil and the rock and allows the remaining oil to be extracted easier. While this method is effective, we cannot store all of the world's carbon in old oil fields. The buildup of pressure in a limited space could cause the rock to eventually crack and release the CO2 back into the air. Another place we could store the carbon dioxide is under the ocean floor. Pressure at the bottom of the ocean would be high enough to keep the CO2 in a high-density state that would keep it from leaking into the ocean. Some other methods for carbon sequestration are biological sequestration and utilization. Biological sequestration refers to the storing of carbon dioxide in living organisms. This method is currently being researched by the United States Geological Survey and has promising results. However, the massive scale of the carbon dioxide problem means that biological sequestration on its own isn't enough. One other method would be to use carbon dioxide to create a variety of consumer goods such as fire extinguishers, carbonated beverages, fertilizer, and various polymers. The best solution to our carbon dioxide problem would be to use a combination of these methods to capture and store CO2. Doing so allows for massive amounts of CO2 to be removed from the atmosphere while ensuring that it is safely locked away.
In terms of national readiness for geological sequestration, the U.S. Geological Survey recently completed an evaluation of the technically accessible storage resource for carbon dioxide in the onshore areas and state waters of the United States. Based on current geologic and hydrologic knowledge of the subsurface and current engineering practices, the USGS assessment team obtained a mean estimate of approximately 3,000 metric gigatons of subsurface CO2 storage capacity that is technically accessible within the U.S. This amount is more than 500 times the 2011 annual U.S. energy-related CO2 emissions of 5.5 gigatons. The area of the assessment with the most storage potential for carbon dioxide is the coastal plains region, which includes coastal basins from Texas to Georgia and accounts for about 65% of all available storage. In terms of national readiness for biological sequestration, the USGS investigated carbon storage capabilities between impounded and naturally tidal freshwater marshes along the lower Waccamaw River in South Carolina. The results strongly suggest that the long drainage period and moist soil management limits carbon storage over time, meaning managers across national wildlife refuge systems have an opportunity to increase carbon storage by minimizing drainage and impoundments as much as practicable. Utilization of carbon is the field with the most potential for scientific and engineering progress. To aid in this, the U.S. Department of Energy has funded research and development of aspects of carbon capture and storage since 1997 within its fossil energy research and development portfolio. The Trump administration proposed to reduce fossil energy R&D funding substantially in its fiscal year 2018 and 2019 budget requests, but Congress has not agreed to the proposed reductions. Instead, Congress increased funding in 2018 and plans to continue that funding through 2019. The United States Congress seems ready to tackle this problem, despite President Trump calling climate change a hoax, a Chinese plot, and something he doesn't believe in.